Hey, what's going on guys? In this video we are going to see some examples on de Broglie wavelength problems in chemistry. Now let's look at the first problem. The first question is asking what is the de Broglie wavelength of a 75 gram ball moving with a speed of 42 meter per second. So here the question is asking us to find out the de Broglie wavelength that is given by lambda is equal to h over p. H is the Planck's constant and p is the momentum. Momentum can be calculated using m times v. M is mass times the velocity. So h over m times v. M is provided, mass is provided, and also velocity is provided, speed is provided. So we can plug it right here and find the final answer. H is Planck's constant, that is 6.626 times 10 to the power of minus 34 joules second, divided by the mass, that is 75 gram. We have to convert this one into kilogram. So we can multiply this one by 10 to the power minus 3. That's going to give us kilogram. And then the speed is in meter per second. That's good because that's in SI unit, meter per second. And if we multiply everything, that's going to give us 2.1 times 10 to the power of minus 34 meter. And that's going to be the wavelength. Now let's look at the second problem. The second question is asking what is the de Broglie wavelength of an electron moving with a speed that is 5% of the speed of light. Again, same equation, lambda is equal to h over mv. H is always same, that is 6.626 times 10 to the power of minus 34 divided by mass. Mass of an electron is 9.11 times 10 to the power of negative 31 kilogram, and speed of light is 3 times 10 to the power of 8 meter per second, but they have mentioned this is 5%, so we have to multiply this one by 0.05. okay, and that's going to give us 5% of the speed. And finally, if you calculate everything, that's going to give us the wavelength, and if you calculate, you're going to get 4.85 times 10 to the power of minus 11 meter. And if we want to convert this one into picometer, we can multiply this one with 1 picometer is equal to 10 to the power of minus 12 meter. And if we convert this one, that's going to give us 48.5 picometer, and that's going to be the wavelength for this one. I hope this helps. Thanks for watching.